Alright, it's time to turn to page 13. Time to turn to page 13. We're going to move on and make it more difficult because that's how I live my life. Can't stop, won't stop, my friends. We're going to do some mixed unit conversions. And what I mean by that is that if you look at number 1 gives us a number of moles of oxygen, but number 1 asks for grams. Dun dun dun! Don't worry. Don't get ahead of ourselves. Let's take a look. Don't forget that these coefficients are numbers of moles. Okay, and I'm going to tell you right now, we have something else we can write back on our notes over here. If you see moles and moles in the problem, that is 2 fractions. If the problem has moles of one chemical and moles of a different chemical, that is 2 fractions. But if the problem has moles of one chemical and grams of another chemical, that is going to be the dreaded 3 fractions. You're fine. It's fine. So in this problem where I have moles and grams, that's going to be 3 fractions. We always start the same way, whatever they gave us, 4.35 moles. It says oxygen gas, oxygen is O2. Given over 1, that's not changing. That's totally fine, that's not changing. Okay. And that is where I'm going to start my bridge, by the way, with O2. The question is asking me to find grams of iron metal, so that's the Fe over here. So that's where my bridge is going to end. Okay, we have a bridge, we have our given over 1. I guess it's time to do some more fractions. What goes up must come down, so moles of O2 are going to go on the bottom. We have now used moles of O2 twice. Remember, we have to use moles 4 times. And it's twice with one chemical, which I've done, twice with O2. The other 2 times have to be with the other chemical. So I'm not done with moles. All 4 times need to be in a row. So I'm going to do moles up here again, but now I have to switch chemicals. And my other chemical in this problem was iron. So I'm going to do Fe, iron. Okay, remember, in this mole over mole fraction, this is where my bridge is. So the bottom is my O2 in my bridge, which used 3 oxygens. The top is where my bridge is pointing, which was at not just iron, but 4 moles of iron. From there, before, when we were just doing 2 fraction problems, our 4th mole was in the answer. But now, we can do what goes up must come down again. So our 4th mole is going to be on the bottom here. I've now used moles 4 times, twice with each chemical. It's time to switch again. I can't use moles anymore. I'm totally done with moles now. Twice with one chemical, twice with the other chemical. Now, it's time to switch to the only other thing I have in this problem, which is grams. So I'm going to put grams on top. If you ever have grams and moles in the same fraction, they're going to be the same chemical. So if these are moles of iron and I have grams on top, it's going to be grams of iron on top as well. Now this kind of fraction is one you've done before. This kind of fraction, we're going to go back to what we said before, where anytime we need a number of moles, it's going to be 1 mole. When grams and moles are together, we go back to the old way, that it's 1 mole. If it's moles and moles together, our numbers are supposed to be from the bridge. If it's grams and moles together, we go back to the old way, it's just 1 mole. And just like what we did on our previous unit, where are the number of grams going to come from? Grams come from your periodic table. Iron is 55.85. So that is my number of grams that I'm going to put right here. Now I multiply it out. 4.35 times 4 times 55.85 divided by 3. And I get 323.93 grams of iron. Notice I used moles twice with the first chemical, I used it twice with the second chemical, and I used grams twice. We're still using everything twice, it's just now we have to pay attention to what chemical's written with it. Some other notes we can write ourselves. That if you have grams and moles in the same fraction, it's going to be 1 mole. And your grams come from the periodic table. And that's different than if you have moles and moles in the same fraction. If you have moles and moles in the same fraction, then the numbers come from your bridge. So those are some notes we can write ourselves. Okay? Just a thought. Something to think about. I'm going to do one more with you, and then you're going to have some time to try stuff yourself. Let's look at number 2 on page 13. How many moles of iron 3 oxide will be synthesized if you start with 5.3 grams of iron metal? So this time, we're starting with grams. 5.3 grams of iron metal. That's where my bridge is going to start, at the iron. So this bridge was number 1. We're about to draw a different bridge for number 2. It's pointing at iron 3 oxide. That's this guy over here. If you see grams and moles in the same problem, grams and moles in the same problem is 3 fractions. So I'm going to draw my 3 fractions. 1, 2, 3. Put the given 5.3 grams of iron over 1. Don't freak out. I know this is different than what we just did, but don't freak out because it's really not that different. What goes up still must come down. We can only use each thing twice. I've now used grams twice. I have to switch. The only thing I can switch to in this problem is moles. That's the only other thing I know about iron, is I know moles of iron up here. So I'm gonna switch to moles. A note that we just wrote ourselves is that when we had grams and moles in the same fraction, grams come from the periodic table, and moles, we go back to the old way, moles will be 1. Even though what we wrote over here is upside down of what we're writing right here, that's still true. If you have grams and moles together, they're the same chemical. Moles, we go back to the old way, moles is 1. Grams come from the periodic table, which we already talked about in this problem. Iron is 55.85. Now we do what goes up must come down. Moles of iron on the bottom as well. Now, remember we use moles 4 times, twice with each chemical. Here's twice with the first chemical. I have to use it again a 3rd time. That must be on top of this fraction. The 4th time must be in my answer. But the 3rd and 4th time should be a different chemical. So in this problem, my other chemical is the iron 3 oxide, which is this thing up here. Fe2O3. Yes, you have to label the chemicals. Quit complaining. Fe2O3. Remember, in my mole over mole fraction, we don't just automatically use 1 mole anymore. We use the bridge in my mole over mole fraction. Don't just automatically use 1 anymore. We use the bridge. So moles of iron in my bridge are 4. If I follow the bridge across, moles of Fe2O3 are 2. Now we stick it in our calculator. 5.3 divided by 55.85 times 2 divided by 4. Or you could do 5.3 times 2 divided by this and that. I mean, you're going to get the same answer. 0.047 It 0.0474, that rounds to 0.05. We're still going to keep it to 2 decimal places. Okay. You have problems on the bottom of page 13 to try. You have problems on all of page 14 to try. I am done videoing for the day. Good luck, my friend.